In this lesson, we are going to explore the Pythagorean theorem. This theorem was very useful. We will learn the parts of a right triangle. We will learn how to identify if a set of side lengths create a right triangle. We'll learn how to apply the Pythagorean theorem. First of all, let's look at the parts of a right triangle. In our diagram, you notice that we have the right triangle, which has a right angle. The two sides that create the right angle are known as the legs. Typically, the variable a and b are used to represent the legs of a right triangle. Across from the right angle that side is called the hypotenuse. The hypotenuse usually is represented with the variable c, and it is always the longest length of a right triangle. In your notes, write down the Pythagorean theorem. The formula is a squared plus b squared equals c squared. So what they're saying is that the length of A, if you square A, you're going to create this square here. Then if we take the side length, the leg B, and we square it, if we were to add this square plus this square, you're going to get the sum of C squared. So A squared plus B squared is equal to C squared. Let's take a look at some examples. So again, we're going to remember our formula for the Pythagorean theorem is A squared plus B squared is equal to C squared. So we can see in this example that this square is 4 squared. So that means that A is 4. And this area is going to be 16. Then this leg is 3 units long because we have 3 squared. So this area is 9. We said 3 times 3 gives me 9. So we have 16 plus 9, and that gives us 25. So this large area is 25. So our A value is 4. Our B length is 3. Now, to get the C length, we know that the area of C squared is 25. So we simply just take the square root of 25 to get the value of C. So the square root of 25 is 5. Let's look at example 2. A value is 15. Our C value is 17. Now we're going to get the B value. So this area, this square area is 225. This square, the area of this square is going to be 289. So we know that this square plus this square equals the large square 289. So let's plug this into our theorem. So we have A squared plus B squared equals C squared. So we had 225 plus some value squared is equal to 289. Now to get this area, we're going to subtract 289, subtract 225. That's going to give us 64. So this area is 64. 225 plus 64 is 289. To get the actual B value, we had to take the square root of 64, which gives us 8. So let's take a look at this square. So this was 15 times 15. That's how we got 225. This square was 8 by 8, and this squared was 17 by 17. Okay, example 3. We don't know the A value. We know our B value is 5. We know our C value is 13. Now let's plug this in. We have A squared plus B, which is 5, squared, equals C, which is 13, but the theorem says to square it. So we have a squared plus 25. Oh, let's write this in their squares. So this is 25, and this area is 13 by 13, which gives us 169. Now, we need to know the area of this square, so we're going to subtract out 25. So we're going to subtract, we'll just use in our equation, and when we subtract out, a squared is 144. So this area is 144, but we want to know the length of the side of the square. So we take the square root, and when we take the square root of 144, we get 12. Okay, let's look at these examples. So here are 3 squares. If we were to arrange those, could we create a right triangle? In order to do that, it says that we would add the squares together, the 2 squares, the 2 smaller squares needs to equal the larger square. So we would have 16 plus 49 equals 81. We add the left side and we get 65 is equal to 81. This is false. So these 3 squares could not create a right triangle. The next thing that it asks is if it did, then we would circle the squares that would give us an integer for the side length of the triangle. So this does not give us one, but just to give you an example, if I take the square root of 16, I get 4. So that would give us an integer. The side length of this square is 7, and the square root of 81 is 9. So these 3 squares are perfect squares, but they just don't provide the right triangle. Let's look at example 5. We have 18, so that area of 18 plus the area of 54 needs to add up to the area of 72. When we add the left side, we do get 72 equals 72. This is true. So yes, this would create a right triangle. But if I want to take the square root of 18 to get the side length, this is not a perfect square. 54 is not a perfect square. There's no number to multiply by itself that would give me 54, nor is 72. So yes, this gives me a right triangle, but none of these are perfect squares. So we would have to estimate to get the side length. Number 6. 6 squared, so we're going to have 36 plus 8 squared is 64 equals 14 squared, which is 196. When we add these, the left side together, we get 100 equals 196. This is false, so these do not provide a right triangle. Okay, in these last examples, we're going to take a look at the statement and we're going to see if it is a true statement or not. If it is true, then it creates a right triangle. So on the left side, we're just simply going to square 7. We get 49 plus 3 squared is 9 equals 10 squared is 100. And we can see that this is a false statement. Therefore, a right triangle would not be produced. Example 8. Let's see if this is a true statement. We have 36 plus 64 equals 100. We add the left. And this is a true statement. Therefore, a right triangle is produced with the side lengths 6, 8, and 10. 6 and 8 would be our legs, and 10 would be our hypotenuse. Our last example, we have 144 plus 36 equals 324. When I add these together, 46 gives me 10, 8, so 180 looks like. This is false, so this would not produce a right triangle. So on the next few problems, you practice these.